Hello students, this is lesson U4A02a. By the end of the lesson, you should be able to say, I can use properties of sides, angles, and diagonals to identify a parallelogram. So just to recap, in the previous lesson we talked about polygons and different properties associated with polygons. We came up with formulas, describing the sum of all the interior angles, the sum of the exterior angles. In this lesson, we are going to be talking about a very specific kind of polygon, which is a quadrilateral. And I briefly talked about this in the previous lesson. But what exactly is a quadrilateral? A quadrilateral, as the prefix here suggests, we're going to be dealing with four sides. Quad, right? So it's a four-sided polygon. And in the next lesson, and actually in the next couple of lessons, in this unit, we are going to be focusing our attention pretty heavily on just quadrilaterals and not on polygons. And we are going to be studying all types of different quadrilaterals that can be formed, with certain restrictions. Because right now, quadrilateral, or polygon in general, there's no restriction. The only restriction is that it has to be a 2D shape, and it has to be a closed figure, right? And in this case, a quadrilateral, it's just a 2D shape that with four sides. So what kinds of restrictions can we put in place? Well, that's where this comes in, a parallelogram. So a parallelogram is a very specific kind of quadrilateral, and as the name suggests, there are going to be lines that will have to be parallel to one another. So let's take a look. So one of the very definitions of the very definition of what a parallelogram is, we have the quadrilateral has to have opposite sides parallel. So this is our starting point. Opposite sides must be parallel. And again, this is the overview of all the different properties that we are going to be using, so I encourage you to pause the video and just make a note of this, because we are going to be using all this information from now until the end of the year. So it is super important that you do have this information internalized as you are going through the different types of exercises. Alright, so getting back to this. This is the very definition of what makes a quadrilateral, a parallelogram, is the very fact that we have opposite sides are parallel to one another. So this is our springboard to coming up with the other properties associated. And if you recall, just a moment ago I flashed this. There were 5 properties. We're going to go through each one of them and explain why each one of these are true based off of this one fact here, that opposite sides are parallel. Okay, so why exactly are opposite sides congruent? So if you take a look at this, we have opposite sides are congruent here in this property. So what I want to do is I want to take a step back and take a look at this. If I were to draw a line right down the middle here, you can see that I now have formed 2 triangles. So these 2 triangles, we can tell, should be congruent to one another. Why is that? Well, if you notice, side BC and side AD, they happen to be parallel sides, right? Or opposite sides, they are parallel there. So therefore, they must form these angles, which are going to be congruent. And these angles have a specific name. We went over this in Unit 2. Actually, no, I take that back. We went over this in Unit 1 when we talked about parallel lines. So these 2 angles are going to be congruent because of alternate interior angles. These 2 angles over here should also be congruent because of, again, alternate interior angles. So these sets of angles are going to be congruent because of alternate interior angles, because of those opposite sides there. Now, taking a look at this, right, can you justify why is triangle ABD congruent to triangle CDB? If you're thinking, well, it's because of angle side angle, then you're absolutely right. And because opposite sides, and because these 2 triangles are congruent, we can then justify that corresponding parts of congruent triangles must be congruent. So therefore, I can say that opposite sides, these opposite side, must be congruent to this opposite side. Which brings us to the second property here. All right, so our next property, okay, well, yeah, it's nice to have opposite sides congruent, but, you know, are there anything else that we can say that also can justify a quadrilateral to be a parallelogram? Absolutely. And that is if diagonals bisect one another. So how is that possible? So if you look at this, okay, I want to take a step back again. So I have this property already proven, which is opposite sides are congruent. I want to do this one more time. I want to draw a diagonal, two diagonals this time, because I want to show that the diagonals bisect one another. So if you look at this, okay, immediately having established the following, which is that this side, or actually, that angle there, okay, is going to be congruent to this angle here because of alternate interior angles. We also recognize that this angle over here is going to be congruent to this angle over here because of, again, alternate interior angles. Now, just look at this. Just look at this. I am going to highlight the triangle I want you to focus your attention on, which is going to be this triangle here. And this triangle here. And there's actually one other angle I want to point out, which I forgot to distinguish, which is this angle over here. Why am I putting 3 tick marks? Because this angle here doesn't necessarily have to be equal to any of those angles that I've already marked. So if you look at this, okay, the 2 triangles that I've highlighted, okay, they must be congruent because of, why again? That's right, it's because of angle, angle, side. So those, because of that vertical angle being in place, and because of the alternate interior angle, and because of the opposite sides being congruent, we now recognize that the 2 highlighted triangles should also be congruent. So because the 2 highlighted triangles are congruent, I am just going to quickly erase this so that it's less busy and that we can focus our attention on what's important. We can then say that this side must be congruent to this side, and we can also say that this side must be congruent to this side. Okay? So those diagonals, the 2 diagonals then, must bisect one another, because if you look at this, okay, the 2 diagonals are broken into 2 equal halves, which then brings us to this property. We've just proven it. We just proved it. All right, so now we have another property to go over, which is this one right here. One pair of opposite sides are parallel and congruent. And for this, I'm just going to quickly explain this by drawing this out. If I have triangle ABCD, quadrilateral ABCD, and again, I am going to draw a diagonal line through, and I'm going to say that we have only one pair of parallel sides being parallel and congruent. Okay, if you look at this, I immediately recognize that I'm going to have alternate interior angles congruent. I immediately recognize that the 2 triangles, okay, are sharing that diagonal there. So therefore, the 2 blue triangles right now should be should be congruent because of side angle side. And if these 2 triangles are congruent because of side angle side, we can then declare that the opposite side over here, that these 2 corresponding sides should also be congruent. And if these 2 sides are congruent, we can then declare that this angle over here should be congruent to this angle over there because of corresponding parts of congruent triangles are congruent. And lastly, AB must be parallel to CD because of, you guessed it, alternate interior angles. Okay? So therefore, AB and CD must be parallel to one another. All right. So if we have at least one pair of sides that are opposite, parallel, and congruent, then therefore we can say that this is indeed a parallelogram. Last, we have the last property is opposite angles are congruent. And then to do this, okay, what I'm going to do establish here is recognizing this fact. So if we have a parallelogram like the one I have shown here, okay, and we recognize that the diagonals bisect one another, and we also recognize that the opposite sides are congruent, okay, and these angles here are going to be congruent because of vertical angles, we can then establish that these, and I'm going to use a blue highlighter here, we can immediately recognize that this triangle must be congruent to this triangle because of side angle side. We can also recognize that this triangle in orange should be congruent to this triangle that's in orange because of, again, side angle side. All right, so because we know that these triangles are going to be congruent to one another, we can then establish this fact, which is, and I'm going to use red, okay, that if I call this angle A, and this is angle B, I immediately know that this angle here must be A, and this must be B. And if I call this angle over here C, this angle must be C. And if I call this angle D, this angle must be D. So let's just take a look at this, okay? Opposite angles, okay? What is angle B here made up of? Oh yeah, this angle over here is lowercase b plus lowercase c. What is this angle over here? Oh yeah, that's again lowercase b plus lowercase c. What's this angle over here? Oh yeah, that's lowercase a plus lowercase d. And then lastly, this angle over here, this is lowercase a plus lowercase d. Can you recognize that opposite angles indeed are going to be the same, right? I have b plus c. What's the opposite of this? Also b plus c. I have over here a plus d. What's opposite of that? Oh yeah, it's also a plus d. So yes, opposite angles are congruent in a parallelogram. Let's take a look at some examples together. So here, what we want to do is we want to talk about parallelogram ABCD, and we are going to be solving for sides A, B, B, C, C, D, and AD. Immediately recognizing that opposite sides should be congruent, I'm going to have you pause the video for a moment, see if you can solve this. Hopefully you guys had some time to think about this, and then recognizing that 2x plus 1 is equal to y, and then similarly 3x plus 4 is equal to 5x, we can then establish these relationships and solve for x. I can subtract both sides by 3x and then divide by 2, leaving me with x is equal to 2. So if x is equal to 2, I can then solve for what AB is. AB therefore is equal to equal to 10. CD, therefore, is also equal to 10. AD is equal to 2 times 2 plus 1, which is equal to 5. So therefore, BC, which is the letter Y, should equal to 5. All right, let's take a look at the next one here. Again, we need to solve for angles A, B, C, and D. So looking at this, I'm going to have you pause the video and see if you can solve this on your own. Hopefully you had some time to think about this. So looking at this, angle A and angle C should be congruent because those are opposite angles. And recognizing that opposite angles in a parallelogram should be congruent. So I can say 3x plus 10 is equal to 2x plus 30. Subtract both sides by 2x. I end up with x plus 10 is equal to 30. Subtract both sides by 10. I end up with x is equal to 20. If x is equal to 20, I can then say that angle A and angle C will both equal to 70 apiece. And wait a second here. Because side BC is parallel to side AD, and this is in fact a parallelogram, right? So therefore these angles over here, angle B and angle A, should be supplementary, right? That's one way of thinking about it. Angle A and angle B should be supplementary. Another way of thinking about it, angle B and angle D should be the same, right? So if I add the two, if I add all four angles together, 70 plus angle B plus angle D, but angle B and angle D are the same, I can call angle B the letter y, okay, and say the following. I can say 70 plus 70 plus y will equal to 360. And I can solve for y that way, okay? If I do this, I end up with 140 plus 2y is equal to 360. Subtract both sides by 140. I can say 2y is equal to 220, or y is equal to 110, or angle B and angle D are both 110. Either way of thinking about it. You can also think of the angle A and angle B as being supplementary as well. So, therefore, angle B, again, is 110. All right, so quadrilateral ABCD is a parallelogram. Here you need to solve for side length AE, BE, and BD. So looking at this, okay, I gave you side length AE, AC, and BE. Pause the video, see if we can figure this out. And welcome back. So AE is equal to 4 plus 3x. And then AC is equal to 26. So wait a minute, what do we know about AE and EC? Well, we recognize that AE and EC are going to be the same. So therefore, we can say that AE plus EC should equal to 26. But since AE and EC are the same, we can say 4 plus 3x. We can say 2 times. I'm sorry. We can say, since AE and EC are the same, we can say 2 times AE is equal to 26. So we can solve for what AE is. So we can divide both sides by 2. So AE is equal to 13. If we know what AE is 13, we can then figure out what x is. So I know that 4 plus 3x is equal to 13. Subtract 4 and divide by 3. We end up with x is equal to 3. If x is equal to 3, we can then solve for what BE is, right? So BE, therefore, has to equal to 6. And if BE is equal to 6, we can also figure out what is BD, because BD is going to be double that of BE, because we know that diagonals bisect one another. So therefore, BE and DE are the same. So therefore, BD will equal to 2 times BE, or BD is equal to 12. And that's it.